Hello, good morning, good afternoon, good evening, depending on where you're at. My name is Luke Allstott. I am currently a student at Oakland City University. I am taking STEM Math 570, History of Mathematics. A little behind the scenes about me. I am a high school teacher at White River Valley in Swiss City, Indiana. I currently teach Algebra 2, Pre-Calculus, and Calculus. But enough about me. Let's begin the final project for this semester. The project I chose was Project 19. For those of you at home wanting to join in, the question was, do most women think about mathematics differently than most men do? If so, how? Your opinion is solicited here. There is no definitive psychological research on this question yet. If your answer to the first question was no, then this project is not for you. If you answered yes, read on. Assuming your opinion is correct, in what ways might mathematics have developed differently if it had been originated primarily by women? Provide specific illustrations if you can. In my final paper, I link the absence of a strong female presence in mathematics history to the current trend of an underrepresentation of women in science, technology, engineering, and mathematics jobs. I believe the main reason for this is the classification of STEM jobs as a masculine profession, and that Sandra Harding says it best. Women have been more systematically excluded from doing serious science than performing any other social activity except perhaps frontline warfare. Nevertheless, statistics don't lie. Women today fill close to half of all U.S. jobs. They hold, however, less than 25% of STEM jobs. And more devastatingly, women with STEM degrees are less likely than their male counterparts to work in a STEM occupation. Into my final paper, I have collected data from my classroom. I have 76 students total with an average grade of 70.67 that range from 23 to 104. I then split the data into two categories, males and females. The females in my class have a 76.76 average, which is higher than their male counterpart average of 62.97. I used a student t-test to analyze the data with a null hypothesis that the males and females have the same grades. I inserted an alternate hypothesis that females have a higher grade than their male counterparts. In conclusion to the student t-test, it resulted with less than 0.01 significance that the null hypothesis could be rejected, and that the females have a significantly higher grade in my classroom. Additionally, I have inserted the behavioral and brain functions research that shows that there is no difference between males and females' mathematical performance. However, there was a significant difference in math anxiety and test anxiety, where girls have a higher anxiety level than their male counterpart. In conclusion, my research coincides with Yu's statement that female students have better grades and are less disruptive than their counterpart boys in the classroom. Additionally, Devine et al.'s research shows that girls have higher mathematics anxiety and test anxiety than boys. However, no research was found illustrating how women have affected mathematics history in the way we represent it today. I do believe that further research is warranted in order to be more definitive. I would like to end this presentation with the brief story of Newton and Leibniz developing calculus. This is an example from math history that the creator gets to represent mathematics in their best interest. It would be interesting if more women had been involved in these duels to see how our mathematics language may have changed.